The example 1, I have a 3 by 3 system. And this X, as you know, should have 3 components. You should have, let's say, X, Y, Z. How about that? So that's your structure of the function. They are all functions for t. What I need to do is to check, take the derivative for each of those functions equals the multiplication of this. So let me check 1, then the rest all do the same way. Take the derivative to the first solution. You do not need to take any derivative to a constant. And when I write it down this way, it's the same as you multiply in, is e2t, e2t, e2t. It's better to factor it out. And then all you need is take the derivative to the function. Well, if you want to do this way, it's the same. Look, that's e2, e2t, 2, e2t. Take out the 2, no, take out the e to the 2t, and the 2 again is the same. That's the left hand here. How about the right hand? The right hand, you need to multiply this e to the 2t, 1, 1, 1. Maybe you do not get used to that. Let me just multiply this e to the 2t, e to the 2t to see what you get. 0, 1, 1. And you remember how to multiply 3 by 3, multiply 3 by 1. We learned in the very beginning. 0 times this is 0. Let me draw a line. This is 0. That's e to the 2t plus another e to the 2t. And the second line, let me change the color. This to this is e to the 2t. That's 0. That's another e to the 2t. And the third one, and this e to the 2t plus this one e to the 2t and the plus 0. Well, obviously, you got the 2 e to the 2t. Well, look, which way you want to write. That's the same. So the left equal the right. Equal what? Equal twice e to the 2t times 1, 1, 1, or you can write it down this way. It's up to you. So we checked 1, but that's not enough. We need to check another one. You can do it yourself in home. You take the derivative and you do it on the left, and then you multiply the matrix to the same thing on the right. They should be equal. So after you get this, how does my solution look like? My solution will look like this. The xt will equals to c1, the x1t, which is e2t, 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 plus c2, the second one, is negative e to the negative t, 0, e to the negative t, plus c3, the third one, e to the negative t, e to the negative t. Then you're going to say, hey, how can you be these are the same? Of course the same. Look, if we want to write it together into what? 3 by 1 vector, this is c1 e2t minus c2 plus 0 here, c1 plus 0, c3, and c1 plus c2 plus C3. That's this. Look at this one. You multiply C1 e to the 2t minus C2 e to the negative 2t, negative t, 0. See? The same. Right? To the second one. C1 e to the 2t plus 0, C2 e to the negative t, C1 e to the 2t, C2 e to the negative t, and the C3 e to the negative t. So that's one way, and this way is exactly the same. So a general solution can be written as the linear combination. I call it a linear combination, like this. Or the best way we like is fundamental solution set matrix times a constant matrix, constant vector. That's the way we prefer. So what's your solution? Your solution is write as x equals this and times c. A little bit of convention. In the mathematics book, when you talk about such a complicated system, we use the capital letter usually for matrix. We use bold face or an arrow on the top, talk about a vector. And then we use the small letter like this for scalar. And your first question is, what is it? Is a matrix, is a vector, or is a scalar? If you do not know this, of course, nothing makes sense. Well, let me check another one. Before you solve anything, know how to do it, you need to know how to check it. This time, not only need to check about it, this is the solution, but also need to check the initial condition here. The initial condition is easy to check. When t equals 0, look, this x is 0, you just put the 0 to here, equals 5 e to the 0, which equal 1, cosine 0, 1, sine 0, 0, then cosine 0, e to the 0, 3 cosine 0, minus sine 0. Of course, that's 5, 3. That's this. So you checked. How do I check the solution? I take the derivative by the product rule. The derivative of this is it itself. You take the derivative to this one first, plus take the derivative to cosine is negative sine t. That's what you get. And to take that derivative, it's it itself. Take a derivative of this one first. And then keep the first. Take a derivative of the second. And the minus cosine t. That's the left hand. Now you can reduce a little bit. When you reduce, and take the et out, 5 out, that's a cosine t minus sine t, the first row. The second will have 3 minus 1 is 2, take the et out, 2 cosine t, negative 4 sine t. That's on the left hand. That's the left. How about the right hand? Negative 2, 5, negative 2, 4 times this function 5 et cosine t et 3 cosine t. You do the multiplication. Negative 10 et cosine t and plus 5 et 3 cosine t. That 3 is bad. minus sine t. That's the first row. The second row is the same here, negative 10, and then 4 make the 4 et 3 cosine t. Well, we just need to check now. Negative 10 plus 15, you got a 5. That's right. The cosine is right. The sine is negative 5. That's right. The sine is negative 5. See? 5 times negative 1. And look at the second row. Negative 10 plus 12, that get a 2. That's right. And then minus 4, that's right. So now you checked it. So before I move to how to solve it, let me summarize. You learned 2 definitions, the Wronskian and the fundamental solution set, or say general solution. And then you learned the 2 theorems. One is called the superposition principle. That's how you add to the general solution. And another one is if the Wronskian is not 0, they guarantee linearly independent.